Welcome to The Explainer. Today, we're going to do something kind of wild. We're going to take a look at one of the biggest ideas in all of science, Einstein's special relativity, and explore an alternative theory that, well, it turns our whole understanding of space, time, and matter completely on its head. So let's just jump right in with a really big question. We've all been taught that the speed of light is the ultimate cosmic speed limit, something truly unique. But what if that's not the whole story? What if the special status we give the speed of light is actually a huge misunderstanding of what matter itself is?
But before we can really dig into that new idea, we've got to get on the same page about the theory it's challenging. Let's do a quick refresher on Einstein's big idea.
Okay, so at the very core of special relativity is this one really strange but super powerful idea. It's an idea that was backed up by famous experiments like the one by Michelson and Morley, which couldn't find any change in light speed. And the idea is this. No matter if you're standing perfectly still or zipping through space in a rocket, if you measure a beam of light, you will always get the exact same speed, c. Now, for that cosmic speed limit to hold true for everyone, Einstein realized something had to give. Space and time couldn't be the rigid, absolute things we always thought they were. Nope, they have to stretch and squeeze, all depending on how you're moving. And this is what leads to all those famous mind-bending effects like time slowing down, that's time dilation, and distances actually shrinking, which we call length contraction. All right, to really wrap our heads around this new perspective, let's play with a really clever thought experiment. It'll make things a lot clearer. I want you to picture this. You've got these sailors on a submarine, deep underwater, no windows. Their entire reality, everything they know about the world outside their sub, how far away things are, how fast they're moving, it's all measured with sonar. For them, the speed of sound in water is the absolute constant speed of their universe. So if these sailors were to build their entire understanding of physics just from these sonar measurements, they'd come to a pretty wild conclusion. They'd figure out that their clocks must slow down and their rulers have to shrink whenever they move. You know what? They'd end up deriving the exact same equations Einstein did for relativity, just with the speed of sound plugged in where we have the speed of light. Their universe would seem completely relativistic to them. And here's the kicker, right? That whole sonar clock thing, it might sound a little out there, but it's not actually that different from how we measure things. Our most accurate clock, the atomic clock, literally defines time by the oscillations of an atom, a process that's governed by light. We even define the meter based on how far light travels. We have built our reality around the speed of light, just like those sailors built theirs around the speed of sound. So this leads us to the critical question. What if we're the sailors? What if our whole physical reality is the submarine, and the universe around us is the water? This is where the theory really flips the script. It proposes that maybe, just maybe, relativity isn't a property of space-time itself, but a property of matter.
So this model says that fundamental particles, electrons, quarks, all that stuff, they aren't tiny little billiard balls. They're actually a special kind of wave called a soliton. You can think of it like a self-contained knot of wave energy that holds its shape perfectly, which allows it to act just like a solid particle as it zips through space.
And in this model, what we think of as mass, well, it's not some fundamental property. It's simply the energy of that wave spinning around in a tiny, tight loop. That circulation is mass. And then what we call velocity. That's just the entire wave packet moving through space. So you've got these two things going on, the internal spin that gives it mass and the external movement that gives it velocity.
And this is where it gets really, really cool. If you think about the particle's energy like a right-angle triangle, the internal circulating energy, its mass, is one side, and its external forward-moving energy, its momentum, is the other side. The total energy is the hypotenuse. Well, if you do the math on that simple geometry, you know what pops out? E equals mc squared. It's not some separate magical rule. It's a direct consequence of this wave structure. It just falls right out of the math. So this totally new picture of what matter is gives us a completely different starting point for understanding relativity. This is the alternative idea, the new rule for the game. Instead of starting with the speed of light is constant for all observers, it starts with this. Matter itself is waves, and those waves are always locally moving at speed c. So you see where this is going, right? It's just like the sailors on the sub. The reason we always measure light speed as c is because our measuring tools, our clocks, our rulers, even our own bodies are made of the very same waves.
We're trying to measure the medium with tools that are literally shaped by that medium. It's no wonder we get a constant result. And this isn't just some neat story. It actually clicks into place surprisingly well with a bunch of other big ideas in physics. It gives a physical reason for why matter acts like a wave, as de Broglie showed. It helps explain parts of the Dirac equation that seem to show electrons moving at light speed. And it makes total sense of why matter and antimatter annihilate into pure light. The wave just stops circulating and travels in a straight line. It explains all the same stuff, just without having to bend space-time to do it. Okay, so if we run with this new idea, if we accept this new postulate, what does it actually mean for how we see the universe? Well, the two theories get to the same finish line, but they start from totally different places. Einstein's relativity kicks off with an observation that light speed is constant and concludes that space-time itself must be flexible. This other theory starts with a substance of reality, that matter is a wave, and concludes that our measurements of space-time just appear to be relative. And this is probably the biggest mind-bender of all. In this view, there's no warped space-time. All those bizarre relativistic effects, time slowing down, lengths contracting, they aren't happening to space and time itself. They're happening to us, to our matter-based clocks and rulers as they move through a perfectly normal, classical, absolute space. And that leaves us with one really profound final idea. So here's the picture it paints. We're basically living inside a bubble, a relativistic bubble. Everything we can possibly use to observe the universe is made of the same fundamental waves. We're exactly like those sailors, totally unable to measure our own motion through the water because our measuring sticks are made of that same water. It's a perfectly self-contained system. And that's the big, fascinating, open question this whole idea leaves us with. What if there's something else out there? Another kind of wave in the universe, maybe like gravity waves, that isn't based on light and travels at a totally different speed? Could something like that pop our bubble? Could it give us a window to the outside and let us finally measure our true, absolute motion through space? It's a question that really forces you to rethink the very foundation of what's real.